Hi there, my name's Martin. Here's what's new in Diffusion 6.6 Preview 1. Regularly delivered preview releases provide early access to features that will be included in the following full release. They are fully supported and production ready. This brief video is ideal for developers and solution architects alike, and we're going to use real foreign exchange data to make it more relatable. This release, codenamed Kura, includes new features for time series topics, topic views, a Kafka adapter, and a Python client. First up, time series topics. This preview of Diffusion version 6.6 includes 3 new time series features. API updates to ease the publishing of time series data, API updates to assist publishing of existing time series data, and you can now visualize time series data right in the Diffusion console. You can now update a time series topic using the same update stream API as is used to update other topic types. To append data to a time series topic, use to mandate the use of the time series API. From version 6.6, the developer can update a time series topic as they would a non-time series topic using the update stream. In the broadest terms, updateStream.set now equates to timeseries.append when addressing a time series topic. This means that upgrading to time series topics does not mean changing your code. However, there are further functional and performance improvements too. Update streams calculate topic value changes in the client, making less work for the server and makes the update transmission more efficient. Update streams can enforce constraints when updating or creating the topic. A developer can give the update stream constraints to go ahead only if the topic doesn't exist, or the topic does exist and holds a specific value, or the topic holds a partially matching JSON value, or the session updating the topic holds a session log. So there's lots of flexibility here. Using some of the update stream features, this code atomically checks that JSON topic myTimeSeries data exists and contains at least a field called state that's holding string value live, and it returns a topic stream if so. It goes on to set the topic 3 times to a JSON value. You will notice how field state does not change, which means that when the delta is calculated, only the value field is transmitted. Let's run this. It's failed and logged that the update constraint has not been met. Let's look into that. Like the error says, there's no state field in there. Let's set that straight. Let's rerun the code. That's worked. Let's see the result. As this is a time series topic, we can see the historic depth of the values as well as the current value. So, using an update stream to append events to a time series topic offers both performance and real functional advantages. Additionally, if you're only occasionally updating topics, topicupdate.set will also transparently append events to a time series topic. You can now append historic data to a time series topic. Previously, the timestamp of a new time series event was decided by the Diffusion server. Using Diffusion 6.6, we can append timestamped events to a time series topic, providing they are in time order. This is ideal if you wish to publish information from an existing time series source, for publishing historic time series data, or for test scenarios where the fidelity of an event is important. Let's look at the code. This small script loads 13 megabytes of financial data, which covers about 4 hours of foreign exchange prices for 10 currencies. Each price is an individual JSON record on a single line of text. Lines 1 to 4 load the libraries we need, all of which we can install from npm. On line 9, we establish the type of the topic to create for each foreign exchange pair. On line 14, we create an async function because we're going to use async features from both Diffusion and readline. Here we check for at least one argument, the name of the file holding the foreign exchange data. And here we build the machinery to read one line at a time. On line 25, we connect a session to our Diffusion server. And here on line 37, we iterate through each of the lines read from the file. We pass the JSON data into an object. Let's take a quick aside to look at the shape of the data. See how each row carries a field called name, as well as a field called TM, which holds the timestamp of the trade in milliseconds. Both of these will be useful in this example. On line 39, we use the name field to compose the related topic path. Remember that you can use any Unicode character on your topic paths. A topic must exist before we append to it, so on lines 41 to 45, we create any topics we need on demand. If the topic does exist, and has the same type, this has no effect, so it's safe to call on existing topics. Then to the star of the show. Here on line 47, we call timeseries.append, which now takes an optional timestamp argument, and here we give it the value of the TM field from the foreign exchange data. Let's run this to create the time series topics holding historic content. Let's have a look at the results of that. Here we are in the Diffusion console, and here is the topic tree that was just created with the time series foreign exchange data. And here below are the historic events where each has a timestamp in the past. We can now visualize numeric data stored in a time series topic. Time series topics are a good fit for storing financial and other numeric data which changes over time. Let's revisit our foreign exchange code and evolve it to store the bid and offer values in separate topics. This code is much the same as before. However, instead of creating a single JSON topic, it also creates separate numeric time series topics for the bid and offer values. Here on line 41, there's a new function to assist when a new topic is created. And down here, we put it to work, creating 3 topics for each currency pair that is processed. This line is essentially unchanged, whereas on lines 62 and 63, we append the numeric bid and offer values to their topics. Let's try that out and see the result. Let's jump over to the console to see the results. We shall use the topic browser to explore the new time series topics. Here is our time series JSON topic that we're familiar with, and here is the bid topic which we're going to visualize for the previous 10 hours. The console displays this chart for all numeric time series topics, and by default shows the last 10 events. Let's change that to the prior 10 hours. Showing the data here in the browser makes it easier to spot patterns and trends in real data. Topic inserts give us new capabilities to enrich your event data. And using topic views to reshape or enrich your data on the server can minimize changes to your client applications. Using the topic insert feature, you can now insert data from another topic into a JSON topic when the source changes. Let's build an example where we insert textual analysis into foreign exchange price data. This is live foreign exchange data, and over here we have analysis on the currency pairs. We're going to build a topic view that merges currency analysis text into the foreign exchange topics when the foreign exchange topics change. Now we browse to the Topic Views tab to create a new topic view. We'll give it a descriptive name. Then we give it the spec. As it stands, this maps everything starting with FX to FX enriched. And this inserts the value of the matching analysis topic into a new object property in the reference topic called analysis. Let's see that working. Here we find our new reference topics. Let's subscribe to them and see the live topic inserts. And here we find our new analysis attribute. This railroad diagram for the insert feature shows its flexibility. You can specify a piece of the data to insert into the reference topic using the key keyword and a JSON pointer. In the live example, we saw how we use the @ keyword with a JSON pointer to make the insertion. And finally, we can insert a default piece of data if the insertion is not possible. This release of Diffusion introduces a Kafka adapter that makes it easy to integrate your Kafka data feeds with Diffusion. The Kafka adapter is in a beta release state. We can use the Kafka adapter to connect Kafka topics to Diffusion topics, and vice versa. Let's take a look at that in action. In this scenario, we have a Kafka topic holding foreign exchange trade information that we need to share via Diffusion. We find the beta Kafka adapter in the adapters directory. This is the configuration we use to achieve our goal. These are the Diffusion server details, and these are the Kafka server details. And here we're associating the Kafka topic fx.data to a Diffusion topic of the same name. And here at the tail for clarity, we state that all Diffusion topics are created with a Kafka path prefix. Let's turn the key and see the results. Now we've started the adapter, let's see the data flowing into Diffusion. Here we are in the console, and there's our topic. Let's subscribe to that. Here we can see the data arriving from Kafka, ready for subscription by another Diffusion client. Last but not least, Diffusion 6.6 includes a preview of Diffusion's new Python client. Introducing the first of a growing set of features, we can use this preview release of the Python client to subscribe to topics as well as send and receive messages. Let us know which features you want to see in it next. Let's see it in action. The Python client is available right now in PyPI, so we can download it with pip. Let's put this code to work and subscribe to and display some topics. Let's see it working first. There, we can see it printing brightly formatted foreign exchange data as it's received from Diffusion topics. Let's walk through that code. At lines 1 to 8, we find the shebang line and the library imports. Here we establish our constants, the Diffusion server location and credentials, as well as the topic selector. These functions handle topic events, starting with the first one, onUpdate. This has delivered the new topic values and renders it as syntax highlighted JSON. The other two handle subscription and unsubscription events. We create this async function to accommodate the async calls made to the Diffusion client. This connects our session to the Diffusion server and gets access to the topic feature, which we shall use shortly. This creates the value stream. Its job is to receive incoming JSON topic updates and dispatch them to the handler functions which we saw earlier. And here we instruct the Diffusion server to subscribe us to the foreign exchange topics. That's only 45 lines of pretty legible and Pythonic code. That's all for version 6.6 Preview 1. Check back in 2021 for the full release of version 6.6.